Hi everyone, in this video we're going to solve RS value calculation question. So let's look at this question first. Determine the RMS value of a sinusoidal voltage of Vt equals to Vm sine omega t. As we talked the RMS value of sinusoidal waveform, we know that the sinusoidal waveform RMS value is Vm divided on square root of 2. Question B is calculate the full-wave rectified sine wave of Vt equals to absolute value of Vm sine omega t. So let's first plot the waveform. So the first half period is exactly the same thing, and the second one is flipped up. If we put this voltage into our Rms definition formula, we will see the Vrms equals to 1 over 2 pi, 0 to 2 pi, Vm sine omega t, absolute value of them, square dt, square root. This part is equal to 0 to 2 pi Vm sine omega t square dt, right? Because this is our voltage square, and for the absolute value it's exactly the same thing. To integrate this part is actually find the area under the squared value, which is exactly same with our first question. So the RMS value of the full wave rectified sines is equal to Vm divided on square root of 2. Let's see question C. Determine the RMS value of a half wave rectified sine wave. The first half is still our sinusoid wave, and the second half is 0. Let's draw the waveform here. If we put this function into our RMS formula, we will see things like this. Vrms equals to 0 to pi, because we only have half of the waveform. And if we draw this part out, the waveform looks like this. And if we integrate this line, it's the area under the line. And the area here is half area of this two. We can say that this part is only half of this part. Then we can simplify this whole equation into half of Vm squared divided on 2, and don't forget the square root. And then we can find the RMS value for half wave rectified sine wave is Vm divided on 2. This is all about today's video. Thank you for your watching. We will see you in next video.